Okay. Uh, Thanks. Yeah, welcome from my side to my talk about automated testing of Qt applications on desktop, embedded, mobile, and web. Up front, maybe just 2 words about myself. So I'm co-founder and CEO of froglogic. And before we founded froglogic in 2003, I worked for several years as software engineer on Qt. Back then it was still Trolltech, which eventually became the Qt company today. Our company, just also very quickly to introduce you, so we are around since 2003. We founded froglogic with the goal to create an automated GUI testing solution for Qt primarily. We are headquartered in Hamburg, around about 40 people working there. Have a quite large customer base of over 3,500 companies today. And of course, since we are coming from the Qt world, we are a long-time Qt partner and working closely with the Qt company and all partners together. About my talk, so I will talk a bit today about the challenge we have in continuous testing of graphical user interfaces and HMIs, especially in the Qt world, what solutions there are, what the challenges there are, and what to look out for. I will do a short demo of how Squish works, and of course have a couple of minutes left afterwards for any questions which you may have. So to start, what we see today, what changed in comparison to maybe 10 years ago, is that we see way more complex user interfaces, especially also in the embedded space. A lot of devices out there with touchscreens, highly complex user interfaces, which require a different kind of testing than we had in those markets before. But of course, they're also still desktop with all the complex user interfaces. Stuff running the web through Qt WebAssembly, maybe today running also on mobile. So we have to cover a lot of different platforms with our UIs, but also the development process has changed. While in the past, typically we developed for a long time on a project, then had a long testing phase before we released to the customer. We have more and more agile development in place where we want to do updates continuously. Customers get updates frequently every week or even more. But all of that also needs to be tested. So the old method of first developing, then testing everything, then releasing doesn't really work anymore. It kind of has to happen all together, and we need certainty about the quality of the code before releasing it much sooner in the development cycle. And for that, manually testing is absolutely not sufficient anymore. So what we need to do is we need to automate the testing. That's quite obvious. That's all developers, or most developers, do unit tests these days, so there's no big deal about that. But that usually doesn't cover testing the user interface, because we test functions, we test classes, but we don't really test whether the application works from the user's perspective. So in order to really cover the whole application, the whole testing, we need to automate the testing from the user's perspective without knowledge of the code behind it. We need to test exactly what the user would do in the end. And for that, we need to pick a tool which really supports the technology which we're testing. In our case here, it would be Qt. So that's why we also started in 2003 with the Squish GUI Tester, because we saw that there are several tools in the market which support GUI testing, but none of them really understood the Qt library. None of them could really identify objects well. So that's why we started developing Squish back then. Today, with the Squish GUI Test, we've rather a cross-platform, cross-technology tool. So we cover the whole range of operating systems which are supported by Qt. We support all the different Qt technologies, Qt widgets, QML, Qt Quick, also Qt WebAssembly now, also some other technologies, and also hybrid testing, which you often see when Qt applications, for example, embed web content through the Qt web engine. There we have Qt widgets or QML on the one side, but embedded you have some DOM trees, DOM elements. And by combining different editions of our tool, you can access both in a single test. Now let's talk a bit about the most important topic, I would say, in GUI testing, which is how does the test tool you use actually interact with your application. So there are two main approaches. One is object-based, the other image-based. Image-based is a much simpler approach, which basically means to identify an object, you save a screenshot of that control, like the screenshot of a button. You save that as a reference. When you run the test again, you search the screen, where is this image located? When you find it, click on it. That works works well without any knowledge about the underlying UI technology, since it's really purely based on rendering. But while it's easy to get started with something like that, it's also very fragile. Because as soon as the rendering only slightly changes, like if you run a different solution, or if the application is deployed on different platforms and you want to run the same test on Windows and Linux, or if just the layout changes slightly, then this recognition method will not work anymore, and the tests will fall apart. So that's why we intentionally chose the object-based mechanism as the primary object identification model in Squish, which means we hook into the Qt library. From that, we can traverse the whole object tree. So we can get access to all objects. We can get access to all properties. This works for widgets as well as QML. And then we generate a unique object name for each GUI object based on a property value set. So property value tuples, or a set of those, which uniquely identifies the objects in the object tree. And with that, you can easily run a test even if the GUI object suddenly looks different, or if the layout is different, or if it's located somewhere else, we will still find the object in the object tree. From there, we can find out where it's located on the screen, and then interact with it. So that method, while it's harder to implement from a tooling side, it's much more robust for creating maintainable and robust GUI tests. We also do support image-based testing on top of that for some scenarios where it's needed, like when you have very graphical views where you really need to check the visual appearance, but that's really more a corner case where object-based testing is the main thing which we support. Okay, to develop tests, you can choose between different script languages in which you can implement your test cases. So we support common languages there. You can choose between Python, JavaScript, TCL, Ruby, or Perl. That's the 5 languages which you support. We include the standard script interpreters there, so there is nothing proprietary in there. You can use the full feature set of those languages for your test scripting, and that makes it quite flexible in what you can do in your test scripts. You can create tests through capture and replay, so you can, I will show it in the demo later, you can record interactions and generate the script code out of that. But typically we recommend that you only use that as a tool to get started, but then you refactor your scripting into reusable function libraries and so on, which are easier to maintain. All of that can, of course, be done in an IDE. And also what's quite important is what kind of verifications you can do. So a GUI test should not only interact with the application, but of course you want to verify the state of the application automatically. And since we can access all the objects and their properties, you can, of course, also verify them. So you can query their values of certain properties, compare that against expected values, and with that generate a test report in the end where we'll see what worked as expected and what failed. On top of that, you can also do visual verifications where you can compare screenshots or partial screenshots and renderings for the more graphics part of the application, but typically you do a mix of both where you stick to property verifications as much as possible due to the reliability, and do visual verifications only where it's absolutely necessary. Okay, on top of that, so we started as a pure script-based test tool, but we found out that there often is a demand that while developers or automation engineers can implement the tests, those are not the people who actually define what shall be tested. So initially we said to really test the application, we need to test it from a user's perspective, which means we need to test the user stories as defined by domain experts who specify what the application should do. And for that, we embraced a method called BDD, Behavior-Driven Development, which is nothing which we came up with, but actually you may know tools like Cucumber or JBehave. So those were the tools who really made this behavior-driven development popular. And the idea behind it is that you define in a human-readable file how the application should behave. So you define features and scenarios, and in the scenarios you have steps which describe how the application should behave for a certain scenario. And that file, the syntax for it is called gherkin. It's really just a few keywords which are defined for the grammar, but it's a lot of free text in there, so you don't really need to learn a lot in order to be able to write those gherkin files which describe the behavior of the application. Now, the nice thing about it is that we can directly reuse those gherkin files for our test automation. So instead of having to come up with scenarios to test, we can just use those gherkin files which already describe the expected behavior of the application and then start automating that. Which means in Squish basically that for each step which is defined in a gherkin file, you can create a script function and then map those steps to the script functions, and then run a gherkin file by calling its associated script functions. Sounds a lot very abstract now. I will show in a moment how that looks like. But the nice thing here is that you really abstract away the test logic from the test implementation, which really makes test maintenance much easier and also makes reporting nicer, since in the end, you can see in this high-level gherkin file which steps passed and which failed. And you won't just get errors that in some script function something didn't work, but you will see this step, which you can understand what it's doing, failed or passed. So that's a very nice method to put on top of the testing and use in the development process overall, which makes also communication across the different units which work together much easier. Now, a few more advanced features you can also do, which is quite important, is do multi-application testing. So if you want to test more than a single application from a single test script, like if you have, say, some device which you also have a companion mobile app which you can interact with, and you want to have a scenario where you talk to a device as well as the app, you can automate such things in Squish because we have support for remote testing and distributed testing. And then there are some more advanced features like support for FMI, which is mostly usable for the automotive industry working with other simulators. From an architecture point of view, and that's I'm showing that because we also asked how can we integrate all of that into continuous integration later. So first, let's understand how the architecture looks like. We started in a very modular way and still are doing it that way, that everything is built up of command line tools. So we have the Squish Runner, which is a command line tool, which basically is the test script interpreter to run test script. That tool connects to a so-called Squish server, which is a small process running on the host where the application is running. And this Squish server in the end starts the application under test, the AOT, and hooks into it. And that hook is basically the module which then gives us access to the Qt object tree. This hook is injected on runtime, so you don't need to modify the application to make it testable. The only requirement is that you link dynamically against Qt. As long as you do that, we can inject that hook while starting the application through the library loader. Through that, now the runner has a network connection to the application or test, and for every command like clicking a button, doing some gesture, querying a property, a command is sent over from the runner through the server to the hook. The result is returned, and that way the test script can be interpreted. Now, for a test development, you use the Squish IDE typically, which is just sitting on top of the Squish Runner, but just uses the command line tools as well. So there's no big magic behind that. In the case of embedded or mobile testing, typically or often you don't want to put the Squish server on the device because it would be an extra executable, and you want to deploy as little as possible in addition to your application. And for that case, you also can build the Squish hook into the application or test as a shared library. And that way, the Squish hook opens up a listening socket so we can connect from the outside to that device and interact with the application. Last architecture slide, you just see I talked about multi-application testing. So a single Squish runner can also connect through several servers to several applications and test to basically run a multi-application scenario. Now, once you have created all your tests, the next step is, of course, how do you run them? So you don't want to just run them through the Squish IDE, but you really want to make the test automation, the GUI test automation, part of your continuous integration. And for that reason, we provide a lot of integration. So basically, since all of the Squish tools are command line tools anyway, you can easily integrate that into whatever tools you want, but we already provide ready-made integrations for a big number of CI systems and test management systems, such as Jenkins, Bamboo, TeamCity, GitLab, whatever you may use, so that you can readily integrate the test execution into those tools, and then together with your builds, your unit tests, also run the automated GUI tests to verify whether a build is okay or not. And when doing so, you will get, depending on which system you use, the reporting integrated in your CI or test management system, so that you, of course, also can drill down into details in case something went wrong. Now, one big problem with that is running GUI tests takes a lot of time. Unlike unit tests, which run in a matter of seconds or maybe minutes if it's a bigger code base, GUI tests can easily take up hours. The reason is the application has to be launched, you really interact with the UI, the script has to wait for the user interface to react, so you cannot just quickly run through it. You can run through it quicker than a human could, but still the application needs time to react, to do their tasks, and that can add up with customers with like 10,000, 20,000 GUI tests, and that can take 2 days to run. So, and that's definitely too much to run on every change you do to your application. So that would hold up the continuous integration quite a bit. There are different strategies to get around that. One is, of course, to just run a lot of tests in parallel, so to add a lot of machine power to cut down the time. That can be one solution, since machine power is typically cheap. But we also offer another way to reduce the number of tests which you need to execute, so that it's not always necessary to run all tests. You could just define a small smoke test suite, which really covers the critical tests for your application, but you can also do it a bit more intelligent. And that's the way I show here. Together with another tool we offer, Coco, which is a code coverage tool, we have information after you run a test, whether it's unit testing or GUI testing, doesn't matter there. After you run a test, we know which test actually covered which part of your source code. So you can then reverse that and find out when you do a patch in your to your source code, find out through that which tests you need to run to cover that code again. And through that patch analysis from data from the past, you can then automatically retrieve the tests which you need to execute to test the changed lines of code of your patch. And that way, you can build that into continuous integration to just run the relevant GUI tests when a change is done, and maybe run the whole test suite only once a week or twice a week, but not all the time. And that makes it much more doable to run automated GUI tests as part of your continuous integration. Cool. So we only have 10 minutes left, so I will try to get through the demo rather quick then. So what I just quickly want to show you is just how do you create such a test through the BDD approach in Squish, through Gherkin, just that you have an idea how such a GUI test actually looks like. So I have here, or let's start with a new test suite. Qt World Summit 19, we test a Qt application in Python. I want to do my test. I test an application called Catalog. I will just quickly show the application. It's just a simple UI which resembles an electric car, where you can change the speed, change the heating, and then you see how many kilowatts are being used. So we want just to automate a quick test on that UI. So I will create a BDD test. I call it energy. And I will start there just describing in this Gherkin syntax my test. So feature, energy, scenario, heat and speed, And then I say, given the UI is running, when I set speed to maybe 100 and I set heating, to 20, then I expect, I think it was 37 kilowatt to be used. So now I have just this empty test description. Squish tells me there are no step implementations. So the next thing is I need to implement all those steps to interact with my UI. So I can start that by recording. Now this control bar tells me what I shall do and record. So the UI is running, I can just confirm that. Then I should set the speed to 100, so I will do that. Let's try to do it. Set heating to 20. Also confirm that. And now I want to verify that we see 37 kilowatts be used. So I'll insert a property verification that gives me a spy view, which allows me to drill down into the object tree and the properties of my user interface. But I can just visually pick the object I want to inspect, which has a value property for which I can insert the verification and finish that. And with that, I see the warnings are gone, and I can now look into my implementation, which has been generated, and see for each step a corresponding script function has been created with the code to do the interactions. We also see how we reference the objects in our test. So we use different properties for the identification. If you want to look at details how that is done, you can go into the object map, and there you see, like, for a given object name, which properties and values are used to find the object, and you could also adjust it to your needs. So now we can just run this test. So we'll go rather quick, and everything passed and is fine. Now, how much time is left? So I won't do more test editing here. I will just show one last thing to run that through the command line, and then you can see if there are any further questions. So for that, I will run the Squish server, and oops, another terminal somewhere. Here we go. And then I run the Squish runner with the suite I just created and generate a report of that. So now I'm running everything from the command line, which also goes pretty quick. Now let's open my web browser and view the report. Oops. And then we get a report generated here. So that's basically what you then would see in your continuous integration. When you include the execution there, you get an HTML report of your test run. So that was a pretty quick run through. There's of course much more one could show, but let's see if there are any questions you have before we close this talk.
Okay. In order to hook into the application, do you need the debug version of the Qt framework, or
No.
release is working too?
Both is working, so the only requirement is that you link dynamically against Qt, because then we can preload a module and override some symbols, but debug or release doesn't matter.
Okay, thanks a lot.
Okay.
Can you also work with dynamic UIs that build upon data? So when do you expect the object tree?
Yeah, so we work on the live object tree, so we never dump it and work on it, so, but we just work with the application as it is running. So it doesn't matter whether you statically create objects or dynamically create them. It's also the same for us. It doesn't make a difference.
Any further questions?
Can you freely choose the scripting language?
Freely, all of the 5. So
one of the
so
5.
Python, JavaScript, Perl, Ruby, or TCL is what we support. Yeah. So because we have to write modules in which build on top of that. So, but I think it's a pretty pretty big choice.
But in general, they all have the same features.
They have the same features from the Squish side, but of course, from what scripting modules they have available depends on the language you use. Yeah.
Okay.
Yeah.
All right. Thank you, Reginald.
Thank you.
Stadlbauer.